This video is about applying the properties of rational exponents. The instructions are going to tell you to simplify the expression, assume all variables are positive, and then it's asking you basically to apply the properties that you already know about exponents. Only now some of the exponents might be fractions. So I start out with a simple problem to review a basic rule of exponents. If you're multiplying two powers together that have the same base, you add the exponents together. Because this is x times x, and this is x times x times x, and so if you're multiplying these together, it becomes x to the fifth power. The shortcut is to add the 2 and the 3. This next example then, when both of my exponents are rational numbers, I'm just going to have to find common denominators to add them together. So I'm looking to do 1/2 plus 2/3. The common denominator will be 6, and so this is becoming 3 over 6, and this is becoming 4 over 6, and so when I add them together, it's going to be 7 over 6. So my exponent here is going to be x to the 7 over 6 power. We can leave it in rational exponent notation. It doesn't say otherwise. Continue applying what you know about exponents. The 1/3 that's on the outside here of the parentheses is going to come in and get multiplied by all of the exponents that are on the inside. So this is going to become 27 to the 1/3 power, which we'll simplify in a bit. P already has a third power on it. We're going to multiply 3 by 1/3, and it becomes p to the first power. Q already has a 12 on it, so we multiply 12 by the 1/3, and it becomes the fourth power. And we just continue simplifying because we know 27 to the 1/3 power is like saying the cubed root of 27. And we know that the cubed root of 27 is 3, so we're going to simplify this to 3p q to the fourth. In this next example, the 14 and the 2 are just coefficients. We treat them like regular numbers, and we're going to simplify that. So that's going to become a 7 on top. The exponents here, we've got x on the top, and we've got x to the 3/4 on the bottom. The rule with exponents is that you're going to subtract the top exponent minus the bottom exponent when you have it in a fraction like this. So we're going to take 1, and we're going to subtract 3/4. We want to get a common denominator, so we're going to need to put this over 4, which means the top is becoming 4 as well. So 4 over 4 is like saying 1. And so when we subtract, it's going to be 1/4. That'll be our new exponent on the x. So 7, x to the 1/4 power. With our y's, we have y to the 1/3, and there's no y's on the bottom to simplify it with. So y stays as y to the 1/3. And with our z's, remember, negative exponents can't be left in our final answer, so we're going to bring this up to the top and make it a positive exponent instead. And so it's becoming z to the 6th. And now there's nothing left on the denominator, so I don't need to show a 1 down there. And I can leave it in rational exponent notation since it doesn't say otherwise. All right, now we get into simplifying with radicals instead of rational exponents. We know radicals and rational exponents are the same thing, right? When we write expressions with fractions as exponents, you could be rewriting them as roots. If they give you the original problem as a root, then we're going to simplify it using our radical properties. So here we're looking for the third root or cube root of 64y to the 6th power. The cube root of 64 we treat as a regular number. See if we can find a number that multiplies by itself 3 times to make 64, which we can because it's a nice whole number 4. 4 times 4 times 4 would be 64. And then how do we simplify the cube root of y to the 6th power? We can think about that cube root out there as like a guard on the porch, and you can come out of the square root sign or the cube root sign or the fourth root sign, whatever it is, if you can come out in groups of 3 for this one, right? Because it's basically like saying the cube root of y to the 3rd and another y to the 3rd. So we could take out the cube root of y to the 3rd as just y, and another cube root of y to the 3rd as just y. Or you can think about it as, well, if there was y to the 6th power inside, I can pull out 2 groups of y to the 3rd. That's how I like to think about it. So if I'm pulling out 2 groups of y to the 3rd, and they're coming out of the square root or out of the cube root sign, then next to this 4, I'm going to have y to the 2nd power because I'm pulling out 2 groups of 3, and that's the final answer. Simplified as much as it goes. Same thing down here, only now the guard on the porch is a 4, so you can only come out of the house in groups of 4. So 4th root m to the 4th power, on our numerator, we're just going to have m. fourth root of n to the 8th power, we can pull out n's in groups of 4, and how many groups of 4 can we take out? From 8, we can take out 2 groups of 4. So it'll be n to the 2nd power. And what happens if it doesn't come out evenly, right? What if you can't pull out an even group of 4 and an even group of 5? So in this case, it's asking us for a 5th root, and then I look at the things underneath, and not all of those numbers have a perfect 5th root, right? 5, you can't split all of those into perfect groups of 5. So this time, some things will be coming out of the root sign, radical sign, and some things will be staying inside, and that's considered simplifying. Anything that can come out should come out. So here we've got the 5th root of 4. Well, 4 doesn't have a 5th root, and we're not going to modify the problem, so we're going to leave that 4 underneath the 5th root sign. Notice I'm leaving myself a little bit of space in front for the things that are going to come out. Next, I see the 5th root of a to the 8th. So I'm looking at the 5th root of a to the 8th. Well, I can pull out groups of 5. So how many groups of 5 can you take out of 8? 1 full group. And that means that a single a is coming out of the radical sign, but there are still 3 a's left over inside. So we'll leave it as a to the 3rd inside. Right, so we pulled out 1 group of 5. There's still 3 left because we have 8 a's to begin with. Then we've got the 5th root of b to the 14th. So how many groups of 5 b's can we take out? Well, we can take out 5, 10, right? So 2 groups of b's. That means b to the 2nd power is coming out, but there will still be 4 b's left over inside. And then the c's, it's c to the 5th power inside, and we're taking the 5th root. So we know that the 5th root of c to the 5th will just be c. So that c gets to come out. And so here's our final simplified answer, even though it doesn't look simplified to you. Everything that came out was able to come out is now out front of the radical, and everything else is left inside. And then if you're given a fraction and a radical, and you're trying to simplify this, in the example that we had here, it worked out perfectly to have no radicals left in your answer. But if it doesn't work out perfectly, you need to pay extra close attention and remember the rule that you're never allowed to leave an answer with a square root or a cube root or any kind of root in your denominator, right? You would have to rationalize this and get your answer as 1 root 2 over 2, right? And simplify that by getting rid of the root from the denominator. So this time we've got a fraction, we've got a root, and it's not going to work out evenly. So before I even start reducing and simplifying this problem, I'm going to look at that denominator, because it's the denominator that matters, and I'm going to see what I can do to modify this fraction so that it does have an even group of 3 on the bottom. Right now it's y to the 8th power. 3 doesn't go into 8 evenly. I can't pull out an even group of 3. So what I want to do is multiply that bottom by 1 more y. Why do I choose 1 more y? Because then it would be y to the 9th power. And 9 has an even group of 3 that you can pull out of it. So why am I allowed to just modify this problem and make it work? Because it's a fraction. You can do anything to the bottom of a fraction as long as you do it to the top of the fraction as well. Because it's really just multiplying by 1. And any expression at any time, you can multiply by 1 without changing the value. So before I simplify this problem, I'm actually making it a little more complicated. So I'm looking for now the cube root of xy on top and y to the 9th on bottom. So yes, I made the top more complicated, but the reason is so that the denominator doesn't have a root after we simplify it. I can't do the cube root of x or y, so I'm going to leave my numerator as the cube root of xy. But the denominator, because it's y to the 9th inside, I can pull out 3 even groups of 3, and it becomes y to the 3rd power. It doesn't say what form to leave the answer in, so you could leave the answer in this form. If you wanted to go one step further, you can rewrite that numerator with rational exponents instead, because you have x's on the top, and y's on the top, and a y on the bottom. Actually, let's not do that. That's just going to create more work for ourselves, because then we'll have a rational exponent in the denominator, which we don't want to have anyway. So this is actually a better final answer. It's got no rational exponents in the denominator and no roots in the denominator. And that was the whole point of this. So we'll just leave it like that. If they give it to you in radical form, leave your answer in radical form. And that is all.